with Mavo. He's an engineer, of course, and he's the founder of the Venture Foundation. He's the traveling mathematician, physics and science and chemistry buff. And he's very excited to be with us today. Molobut Mavo, welcome back to FGL.
Thank you for having me back. Unfortunately, you won't be seeing my face today. You're going to have to cope with that.
All right. As long as we get the best approaches, we are happy. I'm going to hand it over to you.
All right. Let me share my screen.
Sure.
Right. Okay, thanks for having me back, even though it's going to be a short 30-minute session today. Yeah, I know I was listening for the last hour and a bit. Lots of good stuff there. It's nice to see that people find inspiration from physicists like Richard Feynman. I'm hoping that the learners here are gonna also come up with their own study techniques or methods that will inspire people from their communities to pursue better approaches to learning about information. Last time I was here, we spoke about learning and studying. I thought today maybe we'd focus on just mathematics and how to approach it in a test and exam situation. I mean, it helps that this group is a high-performing group. So you will take whatever works for you on top of what you are already doing. I noticed that some people were not performing well with their course subject or accounting or anything that wasn't maths or science. I want to bring your attention back to this young man, Anati. He was a high performer this year, end of 2017. But when I'd been working with him since 2015, he struggled with isiXhosa, he struggled with his agricultural subject, and that kind of dropped his average. But he was doing well with the sciences, physical sciences, life sciences, mathematics, English. And he expressed frustration that he just cannot get his marks over 70%, over 80% for these other subjects that were not his interest. And I told him, if you want to get the achievement, which I think drives you, recognized, you're gonna have to make time to improve his isiXhosa or improve English, use some of the skills you're learning for English, maybe to boost your learning of isiXhosa, because it's the same thing. You're learning language. Okay, isiXhosa is the first language, but to master it, you have to understand why you are learning languages. Mathematics is also a language. It's a logical language. So use some of the thinking of mathematics in the languages as well. And he did very well. He did improved his marks significantly in agriculture and isiXhosa to beat everyone in the province that year. Okay, so I just wanted to highlight that, and there's a lot of things I want to say, so I'm going to be limited by time, but I thought we'd focus on general aspects of algebra that you're supposed to master, general aspects of trigonometry and Euclidean geometry. So that might exclude some of the grade 8s and grade 9s there when I start speaking about geometry and trigonometry, but it's things you're going to be learning in the near future. So maybe it's worthwhile listening and seeing how, what are the best practice methods to mastering, studying for that content. I just want to say up front, whatever we teach you in high school is not mathematics in the mathematics sense. It's actually tools in mathematics. We're teaching you basic mathematical tools. I said, you see link there. I wanted to share with you something that's in your future that's gonna hopefully challenge you and not traumatize you. Where's this thing? Okay. Do I do this thing now? Okay, I'm gonna Google it again. UCT paper. Pass rate. Olwethu nisavakala?
I can hear
Crystal.
you. I'm just worried
All
about
right.
being hypnotized, but yes, we're all here.
Don't worry, time is always of a but it's fine.
Yeah,
So
don't worry.
this is an article from the UCT News website. It was published in 2018. We had recorded a significantly high pass rate in the province. But the focus of this article was on the data of people who wrote mathematics. There are a few. So out of over almost 700,000, 270,000 wrote mathematics, which is less than 50%. So over 50% of the learners in high school are doing maths lit, and the rest of you are doing what is called pure mathematics. And I just told you, it's not quite mathematics, but it's the tools of maths, right? And the passing was not good, you know, over 37 passed with 40% and above, which includes the distinctions. But I want you to focus on this. Some universities require 80% pass in maths to qualify to get into commerce, engineering, science, quantitative social sciences programs at the university. Only 5,828 in 2018 of the learners passed with distinction, which is at least 80%, right? Which is 2.6% of the people who wrote mathematics. 2.6% of this number, right, got 80% and above. So that's your challenge. It's a small pool, right? You are the elite. You've chosen to do maths, so you better make this work for yourself, right? Because you want to do nice programs once you get to university if you choose to get to university. But now the trauma is here. Of the kids who got a mark of 90% and above, right? When they do a maths course at university in first year, they pass with the mean average of 64%. So on average, they're getting 64%. Of those kids who didn't get 90%, who got less than 90% in their high school exams, they fail the course.
Sure.
That is now your challenge. You sitting there, yeah, you know, and I'm with you, you know, I'm cheering you on. But I want you to know that whatever you're learning in high school is not quite mathematics, right? So you need to get it right. There's no reason you're not getting 100% for it. If you're not getting 100%, come work it out with us. Let's talk. Let's see what's holding you back and so forth. Because it becomes even more of a challenge in university. So that was that. Now I want to go back to the stuff I wanted to talk about.
I guess this is why the fundamentals are so important. Like you're saying, this is the basis, this is the foundation.
Yes, the basics are very important. The fundamentals are very important. Am I back to my PowerPoint slide?
Yes, you are.
Right. So as I was saying, we're teaching you tools, and the tools we're teaching you is mostly recognizing patterns. And I know you're sitting there thinking, oh, I'm good with patterns. I'm not talking about those patterns. Yes, you have to be good with your linear, your geometric, and your quadratic patterns. But you need to be good at spotting when there's a difference of squares, right? I'm going to share this screen with you just to show you what I mean. You share. Right? I was teaching a kid from Queen's College the other day, and he needed to add fractions. Oh, sorry, he was asked in this question. It's a question I had taken somewhere. The question I wanted to know what the lowest common multiple was between these two numbers he was given. But these two numbers he was given were not numbers. They were variables, they were expressions, right? And you're sitting there thinking, I don't know what a lowest common multiple is. You need to know what a lowest common multiple is, right? You learn that thing in grade 8, master it by grade 9. Onwards, you don't forget it. You need to know what a lowest common multiple is, and you work with it all the time. You just call it a lowest common denominator because you work with it only in fractions, right? But an LCD is also a lowest common multiple. It's the same idea, right? So we teach you how to factorize. 3 methods, essentially. The greatest common factor, difference of squares, and trinomial factorization, okay? In grade 12, you also learn cubic factorization. So you should see differences of squares, ngaphansi kwamanzi, right? To solve a problem like this, it's 1.13. That's the difference of squares. You must see it and use it to your advantage to solve. A lot of you will be tempted to open that bracket, expand it, right, as a binomial. It's going to be longer. It's easier to just see that there's a 3 squared there, there's an x minus 1 squared. Those are the factors and solve, right? Whenever you see expressions where you are adding things, look for the greatest common factor. Huh? Greatest common factor, nice. Don't waste time. The geometry, the algebra we're teaching you is quite useful. You know, it's not quite the algebra of university if you want to do mathematics in university, but the tools are quite useful. And look, there was a problem solving simultaneous equations. When I see this, I'm like, oh, there's a difference of squares. I can split that up into an x squared and a difference of squares. I can factorize the difference. I can simplify better. I know most of you will solve for x, substitute for x there, or solve for y, substitute for y. That's antiquated. If you see a difference of squares, it's a powerful tool. Learn to use it. So you can't use it unless you practice it. So a lot of you think difference of squares is something you learn in grade 12, grade 10, and you must forget about it. And it's a gem. Hear what I'm saying? Use it, right? And so you're not just learning the stuff so that you could answer it. No one's going to ask you, where's the difference of squares? Okay. So we're teaching you to recognize those patterns. When you see a difference of squares or its factors, you must use it, okay? We teach you to count. It's simple in grade 8. By the time you get to grade 12, it's a little bit more complex, right? But it's still counting. So counting is a very useful mathematical skill or statistical skill. Okay. So master counting, be able to count. I've already drummed on about lowest common multiples, lowest common denominators. You must note in the expressions you get whether you are adding or just multiplying. If you're adding, you must look for a common factor. If you're multiplying, you must apply some power laws. Okay, so if you're not observing these patterns, then you're in trouble. You must also learn how to reverse operations. That is, you must factorize. Factorization patterns are there for you. Like I say, if you see the factors of a difference of squares, you must be able to come back to it. I'm going to go back to it and use it. Okay, so if I look at 1.3, right? It looks like a complex problem. You're multiplying factors all the way to a large power, 512, and you're asked to determine what P times T is. To me, this is straightforward. If that's P, and that's the first factor there, that's the difference of squares. There you go. Multiply those two. Difference of squares again. Difference of squares all the way. So now you get the sense that, okay, difference of squares all the way, and you can make a simple conclusion, right? Right at the end, you're going to have something like this. That's also a difference of squares. And the answer is as simple as that. Okay, so difference of squares, I'm telling you, this was a 2020, this year, June paper for the grade 12s. Okay, So difference of squares, I'm going to tell you again, master them, see them underwater. All right? Also, maths, you must recognize maths is comparisons. We like comparing things, numbers or functions. Numbers or functions. Functions are numbers anyway. They just represent a continuous sequence of numbers. So inequalities are important. And for this, I want to show you simple graphs, right? These are straight lines. So you can compare these lines. The blue line H to the left of x equal to 2 is greater than F, which is the red line. But they swap over on the other side, right? So F now is above the blue line. So it is greater than H to the right of 2. When you get these problems, we usually don't say use the graph to figure out the inequalities. And a lot of you tend to multiply and use algebra as much as you can, and you still don't get the answer. If there are graphs, use your eyes. Graphs are visual. You can see this blue graph up until here is above the red graph. Okay, the red graph from that point onwards is above the H graph. Even when we complicate these functions, can I do this? Yeah. So if I introduce a parabola, you can see between that point and that point, the parabola is under the blue graph. Between that point and that point, the parabola is under the red graph. But to the left of that point and to the right of that point, this is all we're teaching you. I know you put equations and then you get lost in the factorization and whatever, but this is all we are doing. Critical values are where these graphs are crossing, touching each other. They mean only that as a reference. They're not. I know a lot of you start writing critical values, changing the inequality to equal signs. Not smart. Just use them as a reference point. Okay. Right, and going back to my, see, I had to prepare a slide a little too quickly because like, oh, I can't talk without a slide. Euclidean geometry, right? It's visual content. Take advantage of it. Use your eyes. Yes, from grade 10, we start teaching you theorems. There's one theorem you learn in grade 10. If I asked any of the grade 11s, I don't know how many of them would remember it. But we teach it, and you're supposed to remember it onwards. When you get to grade 11, we teach you 8 more theorems and 1 axiom, right? You must know a difference between an axiom and a theorem. An axiom is a fact we state without proving. A theorem is a truth that we have proven. Okay, it's a fact we have proven. When you get to grade 12, on top of all these theorems that we have taught you so far, we add 5 more theorems, proportionality and similarity. And you must remember all of them. Okay. And doing geometry problems is the same all the time. If I can find my, if I can find my problem, there it is. Why is it not on the sharing screen?
Probably need to click on share again. Sorry about that.
No, I'm trying to share. New share?
New share perhaps, yeah.
I'm not seeing it in the options. Show all windows. Oh yeah, I had to show all windows. Sorry.
Okay.
So where is it? There it is. Okay. So Euclidean geometry, is it on the screen?
Yes, we can see it.
All right. So these problems are the same whether you're in grade 10 or grade 11 or grade 12, right? We tell you what we have drawn for you. Isn't that nice? All this wording is just to tell you what we have here. So you can confirm facts between the words and the diagram. And we ask you to solve for something, proving two angles are equal. So for the grade 10s, what do you see there? You see parallel lines. So now in your mind, you must start thinking about corresponding angles. You must start thinking about co-interior angles, right? And alternate angles if there are any. For the grade 11s, you must think of the grade 10 ideas and also the ones that you have learned. So in grade 10, you would have learned that this is a quadrilateral. It's a four-sided shape, right? You've also learned about a tangent. So don't get lost. These are things that you already know. All we do in grade 11 when we introduce circle geometry is that we make this a cyclic quadrilateral. It was just a quadrilateral before, but now it is a better quadrilateral because all of its vertices are touching the circumference of the circle. So this is your expected knowledge. You need to know cyclic quadrilaterals, tangent theorems, grade 10 geometry as a minimum to solve this. The best thing to do is to work on this thing graphically. A lot of you don't learn to draw these images. You must sit at home, draw them by freelance. If you have a compass and protractor set, you can use that stuff like we used to do in high school, just to see how easy it is or difficult it is to draw these images. You'd be amazed how difficult they can be if you don't practice them. And also you orient yourself better by drawing them. Identify angles. So I use color. I like a color scheme or variable scheme. So if I name this X, that's X, that's X, if that's Y, that's Y, that's Y. It's easy to track. Okay. When you're answering the problem now using the algebra, you must say why you are stating that fact. It's important in geometry to say why. It's important in all of mathematics. It's just that it's only in geometry, Euclidean geometry, where we insist that you tell us why you've just said something. Okay, that's very important. So from grade 10 onwards, you must master this skill. Right? I've written a lot of words here, but I'm hoping you're getting the gist of what I'm trying to help you achieve with geometry. Sometimes when they talk about an image that's not there, let's say the question talks about a circle that goes through S, C, and R, you must draw it yourself if it wasn't there. Just draw it. And then you can start using the theorems again to see how to prove that there is a circle going through those, yeah. And I'm speaking very fast now.
No, it's fine. We actually don't worry about time with the FGLers. We'd probably run over by a few minutes. So you'll still have your full 30 minutes, but Mavo.
All right. Right. So that's geometry. Trigonometry, you start learning it in the basics of the ratios, right? You must know that trigonometric functions are just ratios, really, right? You must know the basics of the ratio, how they are defined. You must know sine is the opposite side over the hypotenuse side. Cosine is the adjacent side of the angle over the hypotenuse side. In grade 10, we only teach you single value solutions. But in grade 11, you start learning that you must take care to identify both the solutions of a trigonometric function in the relevant quadrants. And by grade 11 also, we teach you how to solve a general solution for trigonometry. Those are the basic things that we can teach you about trigonometry on top of the other fundamentals like periods, amplitudes, and all of the other stuff that you know. I want to show you some animation I created of this circular function. They're called circular functions. So this is a sine function, right? Starting at 0 degrees, sine between 0 and 360 degrees. The quadrants are from 0 to 90. This is quadrant 1, quadrant 2, quadrant 3, quadrant 4. But of course, you know the quadrants in the plane, right? You know quadrant 1, quadrant 2, quadrant 3. quadrant 4. This is why they're called circular angles, because they cycle between 0 degrees and 360 degrees. So whatever the point P is here, it is the point T on the function. You can see how they're linked, right? Isn't that lovely? I think that's very lovely. And you can do the same thing for cosine, for the cosine graph. If I can find it, there it is. Cosine graph, same story, right? It starts at 1, at 0 degrees, goes and cycles all the way to 360. There, the value P, the point P is compared to point T. Okay, so it doesn't quite track nicely here, but that's what it's doing. So you must know this and master it. And I can do the same thing for tan. But I want to show you what a general solution is. Right? Here's a general solution. So this is a general solution for sine. And my graph is sine x. And I'm trying to find the general solution when y is equal to 5, when sine x is equal to 0.5. Right? So in grade 10, you would say, oh, that's 30 degrees. But in grade 11, you start going, okay, in the second quadrant, it's 150, right? But the general solution is all of the intersections of this line of y equal to 0.5 with the sine graph. And you can see they extend to infinity. If you can inculcate this in yourself and say, that's what a general solution is, draw the function that you have, trigonometric function you have, and draw the value that is meant to be equal to. And then you'll understand what you're doing. So a lot of you have the mechanism of writing k times 360 degrees, and k is an integer and so forth. But you don't really know what a general solution is. So you sometimes will limit the integral, and I'll say, I want to know from here to here. So this is 0, 360 plus another 90. What's 360 plus 90? 450, right? So if I want to know what are the solutions for sine of x equal to 0.5 between 0 and 450, there they are. Only those 4. Okay, so in your mind, you should have this image so that you don't get lost in the algebra. Sometimes I feel like learners abuse algebra, the algebraic tools we give them, not really knowing what to do. And then you can waste a lot of time, right? I solve this graphically. Whenever I'm given functions like this, I just draw. If they're drawn for me, they probably are, or I'm asked to draw them on a graphic paper. Then that's it. It's useful. I just draw a straight line if it's equal to a certain value. But it might not always be this simple, obviously, because if I have sine of x equal to sine of x minus 45, that's a bit harder, right? But I mean, I know what to do there, so there's no complication. But that's the general idea of what you might call it, general solution.
But Mavo, I don't mean to interrupt you. There's a question about the kind of site that you're using for these simulations and graphs.
Someone finally listening. Okay. Right. So this is a graphics tool. It has a learning curve, so don't think you're just gonna get there and figure it out. So it's gonna be part of your learning, but I recommend it. I've been recommending it since I discovered it in 2015. Right? This particular tool is called GeoGebra.
Love you. I just asked if that's what it is.
Oh, he knows it?
GeoGebra. I was like, what is that? I think he knows it, yes. Love you. Have you used this before?
Yes, ma'am.
Okay. There you go, Mavo.
Yeah, anyway, so I use it all the time. And that's where I do my drawings when I'm setting tests, and That's where I check some of my facts. If I've solved something algebraically, I'll go test my knowledge graphically on GeoGebra. I mean, there's lots of them. I know two, Desmos and GeoGebra. Quite useful. You can download this on, if you have a smartphone, onto your phone. It's a graphic calculator basically. If you have a laptop, you can download it onto your laptop at home. Right. And I think that's all I wanted to say. And I think I said it within 30 minutes.
You did so well. Thank you. Thank you, Mavo. I just want to let the FGLers know, because there were some of them that sent very specific questions through. And those that are specifically struggling with physics and chemistry, that are falling below that 70% mark, and even with mathematics, that we are allowing for them to have a platform where they can interact with you directly, so you can actually deal with their individual constraints and how they're not peaking above 70%. I just wanted you to announce this too, so it's not just me saying it.
Yeah, I'm happy we're finally getting there. I look forward to it. All
right. I don't see any other questions that are quite broad. If there's any final thoughts, Mavo, just an overall approach to mathematics from grade 12 all the way to grade 10, grade 12 rather. Some are stepping into exams at the moment. Some have just started term 3. It is the final stretch to the end of the year, and there isn't time to waste generally. There's no going back now.
Yeah. I mean, I've heard
there's a hand from Balentle.
All right, Balentle, after Mavo's comment, we can come to you.
All right. So I've heard all the tips about how to study. I think they apply very well in the natural sciences and the physical sciences. They must use them. I liked what I heard from some of the learners who are using those methods already. I recommend them. I recommend teaching to someone else. You know, that's the best way of learning, I've found. Usually in my classes, if I'm in a classroom, I'd ask a few of the learners to prepare the lesson if I think it's a very tricky topic to teach, right? Because they start learning that the knowledge doesn't necessarily just come from my mouth. It comes from the textbook. It comes from other things. So teach others. I've been doing it since 1993. The guys that taught me in high school were my classmates. They did well. They ended up being engineers and chemists and whatever, and doctors. I became an engineer. So it's the best way to learn. Just if you learn something and you want to really figure it out, learn like you're going to teach your little cousin, sibling, classmate, or your teacher even. Sometimes teachers need to be taught as well. So
all right.
Yeah.
Okay, Mavo. I appreciate that. Valentia, you got your hand up, had your hand up. You can put on your mic.
It's not a very serious question. I just wanted to say something, then ask a question.
Okay.
So usually with our mathematics coming from grade 1 up to grade 12, I think grade 1 up to 7 is the stage in which we don't use like a calculator and we do our calculations in our mind. And then the calculator is introduced in grade 8 to 12. And then my friends who are currently in varsity came back and they said that you guys don't actually use calculators in varsity. So do you think that we're being dumbed down when we're being forced to use calculators? Because it seems like it's promoting laziness, because I had to write an NBT for maths and I actually forgot how to calculate using my head, and I was like, calculators are a scam.
Yeah, no, yeah. So NBT is 3 hours without a calculator. That's your destination. Just know that if you have a high dependence on a calculator, you're missing out a lot on learning. So if you're practicing, you don't need a calculator. Practice, add manually. The only times that I think a calculator is really necessary is when you're taking a log of a number or a sine of an angle and so forth. But the rest of the time, the questions as we phrase them, you can write these exams without touching a question, the calculator, a single time. Even statistics, even the statistical bits that look like you just only punch into a calculator, right? You can do them without a calculator. So when you're practicing, do them without a calculator. Use the calculator to verify yourself but don't depend on it. It's a lie that we don't use calculator at university. We use advanced calculators called computers. We use graphical calculators. If you get into engineering, you have to know how to use a graphical calculator. Yeah, I mean, some exams might say don't use a calculator. They won't allow you to bring a calculator. But if it's in your nature to practice without a calculator, you'll be fine. I answer all your grade 12 exams, all your grade 11 papers, all your grade 10 papers without touching a calculator. I don't get 100% because I have to finish the paper within the limited time. Sometimes I don't know how to add 25 and 1. I write 26, you know? I write 27. I write 27 instead of 26. It happens because we've relied so much on calculators. All our phones have calculators. If you're at a store, you just hit your phone to add the prices instead of just looking at them and adding them manually in your head. But yeah, I recommend practicing without calculators. But you need to also master a calculator because you're gonna need it in the exams, for instance, for statistics, like I said. But when you're practicing at home, trust me, you can do a lot of those without a calculator. But in an exam setting, time is limited. So you must master the calculator at the same time. But don't depend on it. You must just know what it is. Okay.
Well, thank you so much, Mavo. We have run out of time. I want to close up with a video quickly and want to thank you for your time. I know we're going to be seeing you again soon. But we'll go, if you could please help us. Oh wait, Olotando has a question. Time is an issue with maths papers. Can you see that question from Olo?
Molweni kakhona.
Yes, Olo. Yes, but
ingxaki, I think ingxaki enkulu kwi-maths esikhe sayibona sonke singabantu abenza i-maths lixesha, because I feel like ixesha abasinika lona lincinci kakhulu compared to i-question abasinika zona, because ezinye i-question awukwazi uzisolve within i-30 minutes. For umzekelo, i-Euclidean geometry, it requires a lot of time uba mawucinge ii-theorems ezithile, because singabanye siyanqaya, abanye ke bayayi-understanda kakhulu. But ke ininzi kakhulu, and kwi-functions kubakho ezaa questions zithi bana if f of x is that, and xa umtshintsha abe ku-h of x, ke ngoku what other equation i-adapt enye equation enjani. Ziba ninzi ezinye ii-question ngoma okay, abanye ke baba ne-pressure because inenza ixesha lenza i-pressure, and abanegqamba then ke ngoku ixesha limshiye, then I fail i-test. But yeah, I feel like ixesha lincinci kakhulu.
We can discuss that in our session there. That's going to be organized by FGL. I disagree with you, but I understand your frustration. So we'll iron it out in the session. You can't master quick solutions if you don't practice for them, right? If you take 2 days to solve one problem, trust me, you won't be able to solve a 5-minute question in an exam, because that's what most people do. Like, I keep coming back to this. I keep coming after 2 days. Solution. So if you don't practice to work faster in an exam setting, you're going to always feel constrained. But it's something that we can practice to master. So don't worry about it. We'll work it out.
All right. Thank you so much, Mavo. Sorry about that. We appreciate your time. I know there's going to be questions that are going to be coming to you directly, so we're going to make sure we curate time for each of the learners that have those questions.
Okay, Odut.